Hello, this is video number 33. This is chapter 6, section 5. And this is all about dividing radicals. So 33 is this one, dividing radicals with one term in the denominator. And video 34 is going to be dividing radicals with two terms in the denominator. So you're going to handle these very separately. And so I separated them out into two different homework assignments for you. So you can focus on one type, and then we'll combine them together when we do a quiz or your chapter test, whichever. All right, so here's the big thing you need to know. No fraction can ever be left with a radical term in the denominator. Ever. If you leave one down there, you haven't done your job. So your job is to remove that radical term. Your goal is to remove the radical term in the denominator by multiplying by a specific fraction. We'll tell you what that is in a minute. And simplifying. Okay, so this is your goal. You are going to remove any radicals that are in the denominator by multiplying. So at some point in your mathematical career, somebody probably mentioned to you that you can always multiply or divide any math problem by the number 1, right? Because it doesn't change it if you do that. So what we're going to do is we're going to multiply by 1, except that 1 is going to look really strange. So here's the easiest way to do this is to actually do an example and then kind of write notes as we go. So if we have the problem 8 over radical 7, we know that this can't be here in the answer, right? You also know that if you multiply a radical by itself, you get a whole number, right? So radical 2 times radical 2 is just plain 2. Radical 114 times radical 114 is just 114. Radical 702 times radical 702 is just 702, right? It doesn't matter what they are as long as there's 2 of them. So what we're going to do here is you are going to multiply the problem, the given problem, by the radical in the denominator over itself. Okay, so we're going to multiply by a fraction. That fraction is going to look like whatever radical's in your denominator, that's going to become my fraction. Okay, so rad 7 over rad 7, this is 1. It's a weird looking 1, but it's a 1, right? And now you're going to simplify. So if I take a look at the bottom, rad 7 times another rad 7 is just plain 7. It's rad 49, right? But that simplifies to 7. So just shortcut that and make it a 7 with no radical. Okay. If you need that step that says this is radical 49 and that's going to reduce to rad 7 over rad 7 and that's a pair and that's your 7, do that step in the middle. But I'm going to assume that I don't need to do that for you. You can do that on your own and add that to your notes. Okay. And then you're just going to multiply out the top. And depending on what's on the top, these can go from very simple, like this one. So you multiply these and you get 8 rad 7. That radical 7 in the numerator is not simplifiable, right? You can't do anything with that. It's prime. So what you're going to do, the only thing left, is to check and make sure that these numbers don't reduce. So if these numbers reduce, you need to make sure to do that. To completely get your simplified answer. Okay. And you're going to see that in the next problem that I do. I just wanted to start out with one that was fairly straightforward so that you could see what's happening. So the green statement here is key. Multiply the given problem by the radical in the denominator over itself. Doesn't matter what that radical is in the denominator. Multiply by that. Okay. So here is a similar problem. This is 2 rad 3 over rad 20. Oh, geez. 2 rad 3 over rad 20. All right, so identify your denominator. It's a rad 20. Don't simplify it first. Just multiply by rad 20 over rad 20. Okay? We'll do the bottom first. Rad 20 times rad 20 is just plain 20. On the top, I'm going to get 2 radical 60. Okay, well now I need to reduce this. I would not also worry about the 2 over 20 until you reduce the 60 because that could change. So I'm just going to take the rad 60 over here and reduce on the side. Rad 6, rad 10, rad 3, rad 2, rad 2, rad 5. So we get a 2 out of here, radical 15. And you have now a 2 from your reduced 60 and a 2 in the front of the 60. So we're going to multiply those together and get a 4 rad 15 over 20. And now you need to check and see if this is reducible. And it is. 4 over 20 is 1 over 5. And so our answer looks like rad 15 over 5. And you can never, ever, ever divide a denominator that's a whole number into a radical. So don't think you can reduce that 5 into that rad 15. That can't happen. This is the answer right here. Okay? All right, so we have 2 more examples. Of course, each one gets a little bit more complicated. And then I just want to point out a couple of the problems in varsity so that you don't fall for the trick that I think they intend to put in there. All right, so the next example looks like this. Rad 5 times 4 rad 2 minus 6 over radical 3. All right, so first we're going to actually distribute up in the numerator, and then we'll deal with the denominator. So let's distribute here. So that's going to give us a 4 rad 10 minus 6 rad 5 over rad 3. Now I'm going to multiply by rad 3 over rad 3. And when you have 2 or more terms, make sure you put those in parentheses and just distribute backwards. So we're going to do that. So this is going to look like 4 rad 30 minus 6 rad 15 over rad 3 times rad 3 is just plain 3. All right, and now you should look to simplify the radicals. A rad 30, hopefully you know by now, doesn't reduce. A rad 15 also doesn't reduce. So there's nothing you can do there. And then your denominator, you need to check and see if the denominator and any coefficient, no, let me rephrase that. The denominator and all coefficients will reduce. So will 4/3 reduce? No, it won't. So you can't do anything with this entire fraction. Even though 6/3 is reducible, they all have to reduce for any to reduce. Okay, so let's just make that a statement. The denominator must reduce into every term in the numerator to reduce it all. And so in this one, this 4/3 is not reducible. So the entire fraction is not reducible. So this is your answer. So 4 rad 30 minus 6 rad 15 all over 3 is the answer to that problem. Okay. Let me show you where this would be reducible. If this 4 right here was a 12 instead, and we had 12 rad 30 minus 6 rad 15 all over 3, then essentially what's happening is you're breaking these up into individual fractions. 12 rad 30 over 3 minus 6 rad 15 over 3. So that would go in there and in there, and the answer to this would be 4 rad 30 minus 2 rad 15, and your whole denominator would cancel each other out. Okay, so this is how that would work if it worked. And sometimes it will, but in this case it did not. All right, one more problem to simplify, and then one I just want to point something out to you. You're going to see some problems that are one big fraction, 8a cubed over 3b, and the entire fraction is in one radical sign. You might also see this, root of 2 over 7. When that happens, just separate the top and bottom. So separate these into two radical terms, okay? For this problem, you would have the root of 8a cubed on the top and the root of 3b on the bottom. For the problem I just stuck over here, the rad 2 7s, you'd have rad 2 over rad 7, and then you just multiply by rad 7 over rad 7. All right, so this guy that we're focusing on is the one with the variables. So I'm going to multiply by rad 3b over rad 3b. And a rad 3b times a rad 3b equals 3b. And then on top, I don't have anything outside, right? No coefficients. So I'm going to get a radical 24a cubed b. And then, just like you normally would, reduce if possible. So can I reduce the 24a cubed b? All right, well, the 24 is going to become a rad 4. Oh, geez Louise. Rad 4, rad 6. This is a 2, so this is 2 rad 6. Then the a cubed is a. We group 2 together, and we get an a rad a. And the b won't come out because it doesn't have a buddy. So now we're going to combine all of these. So outside, outside, and that one's a 1, so 2a. And then rad 6ab. And we're going to put all of that, so that's the 24a cubed b at the top. We're going to put all of it over the 3b. And again, before you finish, leave the radical alone, but make sure you check and see if any of that's reducible. And again, in this case, it's not, right? 2 over 3 won't reduce. The a over b won't reduce. And so you can't reduce any of those, making that your actual answer. Okay? And here's the one you have to be careful of in varsity. They have some in there that look like this, rad 32 over 4. Well, there's no root here. So you don't have to multiply by rad 4 over rad 4. It's not a rad 4, right? This is just a 4. So just simplify the numerator or reduce. And then simplify the whole fraction. So rad 32 is 16 and 2. Rad 16 is 4. So this is 4 rad 2 over 4. And then these would cancel and leave you just rad 2. Okay? All right, that's it. So that was 6.5. Toodaloo.